Hello class, this is 1972 AB number 4. So now, it says a man has 340 yards of fencing. This basically means the total length for the entire project would have been 340, including two separate fields, one to be the rectangle twice as long as it is wide. So here, if you to have one of them being the rectangle, something like this, where twice as long, and then we believe that if x is the width, so that means if this is x, then this has to be 2x, and then and the other one is a square, so we can call that as y maybe. So now, looking at the first part, one thing that we get to realize is this total perimeter here, and we get to realize that this becomes 6x plus 4y must be equal to 340. That's what we're indicating. Now, and then the square field must contain at least 100 square feet of 100 square yards. So that means here y squared has to be greater than or equal to 100, which allows us to say that, hey, y must be greater than or equal to 10. Now, and then the rectangular field must be at least 800 square yards. So that means here we have 2x squared must be 800, or rather it has to be greater than equal to 800. So that means x must be greater than or equal to 20. Now, question number 8. If x is the width of the rectangle, the field, okay, what is the maximum and minimum? So in fact, we already found the minimum, which is right here, 20. But how are we going to find maximum? So this portion is the minimum. Maximum can be found in this way. So let us look into A. Maximum, the fact that x is maximum, because both of them has to add up to 340, then y has to be the minimum. Minimum for y, we know that to be equal to 10. So we get to realize 6x plus 4 times 10 equals 340. That means 6x must be equal to 300. So therefore x has to be equal to 50. That means 50 is the maximum. Therefore x has to be between 50, oops, and then 20. That becomes our first answer. Not bad. Alright, number B. What is the greatest number of square yards that can be enclosed in two fields? Now, greatest implies the derivatives. Square yards, it means area. So now, let us try to work on that. That means we want to find out the area formula first. So, part B. Area here becomes 2x squared plus y squared, but as we know we have three variables, we need to get rid of one. Now, what if we have to get rid of y? So here we're going to solve for y. Then we realize that 4y must be equal to 340 minus 6x. By dividing by 4, we get to realize that y becomes here 85 minus 3 over 2x. So we're going to put this one in place of x, in place of y. Then we now realize that area must be 2x squared plus 85 minus 3 over 2x squared. Because the number is somewhat large, I'm not going to expand it, but I'm just going to leave it as they are. Now, Now, when we take the derivative, a prime, then we'll end up getting something like this. We will have 4x plus 2 comes out, so we end up getting 2 times 85 minus 3 over 2x multiplied by the derivative of the inside, which is negative 3 over 2. Now it'll be easier for us to simplify. Then here 2 cancels out with this 2. So negative 3 will be simply multiplied to this term and this term. So we have 4x already. Negative 3 is multiplied to 85. And we get to realize that it becomes 255. So minus 255. Here we get plus 9 over 2x. Now, if we set this one equal to 0, then the equation that we end up getting is that 4, and then this is 4.5. So in fact, we end up getting 8.5. Looks familiar here. X must equal to 255. Then when you divide by 8.5 on both sides, then we will get x equals 30. Now, and then we're looking for greatest number of square yards. So we're looking for the total area here. Now, we technically have to check it using the sign analysis. Here, x equals 30. Now, if you have to plug in the number beforehand, since 0 is possible, so if you have to plug in 0, then you will realize that we are only left with a negative number. On the other hand, if you have to plug in positive numbers such as 100, then you will realize that this portion would have been positive. So we realize that this becomes the minimum. But once again, we're going to be checking upon for 3 areas. So after all, we're looking for the greatest number of square yards. So x being 30 is the one critical point, and then the other two for x can be 20 and 50. So let us plug in those values. Now, the x here becomes 20, x equals 30, and x equals 50. Area here becomes this formula, so by plugging in, we get to realize that area in this case becomes 2 times 20 squared plus 85 minus, notice 3 times 20 divided by 2, so we can get 30 squared. Now, so we end up getting here we have 400 and 800. So basically, we're going to go for 2 times 20 squared plus 55 squared. 3825. All right. 3825. Now, when you do it to 30, 2 times 30 squared, we predicted that to be the minimum. Let's see if it will be. 85 minus. Now, when you plug in 30, you'll end up getting 45 squared. Now this portion becomes 40 squared, and then this one was as they were. So we will end up getting here 30 3,400 would be our area. And then if you have to put in 50, let's try to see what happens. 2 times 50 squared plus 85. Now let's look at it. So 50 divided by 2, which is 25, times 3 becomes 75. So 75 squared. Now, squared times 2, and here is and we realized it was over 400. So we realized here this will be our maximum. And since they're looking for the greatest number of square yards, I believe we found the answer. Alright, let's move on to the next question.